so today we're going to be looking at 45, 45, 90 triangle. So first, as of now, I want you to find the value of x. Given in this triangle, right angle is given right over here. Let's call it maybe angle C, and here is angle A and angle B. Now, where AC is equal to 4, and then BC is also equal to 4, and I want you to find the value of x. All right, so I'm going to leave you with a little bit of time, and then we're going to continue for this task, 45, 45, 90 triangle. All right. All right, so given that you spent some time working on this question, how would you find the value of x? Of course, one strategy would have been knowing the fact that each side is 4 and then the hypotenuse is x. We can use the Pythagorean theorem. We could have 4 squared plus 4 squared is equal to x squared. All right, then here we have each one is equal to 16. Therefore, x squared must be then is equal to 32. Now, then how can you find the value of x? We can simply take the square root of each side, where x is equal to square root of 32. But when you simplify square root of 32, you will realize that this, in fact, will be equal to 4 square root of 2. Now, all right, then, the hypotenuse is equal to 4 square root of 2. But when you look into this triangle, you will realize that this is not only a right triangle, but also an isosceles triangle. All right, and each side is equal to, since each side is equal to each other, what do you realize about these two angles? That's right, since this angle is equal to 90, sum of angle A and B also has to be equal to 90. But when you have to split that into two portions, each one will be 45-degree angles. All right. Knowing that, let me try to get you another question, and we're going to talk about this one further. So I'm going to get you another question with a triangle right here, and I'll say this one is a right angle right over here, and I will also mention that this angle is 45 degrees. And how about the opposite of 45-degree angle? We'll say this side is equal to, how about 6? Okay? And I want you to find out the value of x right over here. How to approach this question? In fact, if I give you the double screen, you might have a better idea. All right, so you can pause the video, or you can continue to work on it together with me. Here, one thing that we get to realize is that since this is a 45-degree angle, what will be the measure of the other angle? That also must be 45 degrees. Because the way which we can find would have been from 180, we have to subtract 90 for this right angle, and another 45-degree angle. That would have been equal to 45 degrees. That means this is an isosceles triangle, which gets you the other side also equal to 6. And this question is practically the same question as before. Let's see what happens. We'll have 6 squared plus 6 squared will be equal to x squared. The way which we can do this one would have been simply 36 plus 36 will be equal to x squared here, where x then must be equal to square root of 72. We got 72 from adding 36 and 36. When you simplify square root of 72, you will realize that this will be equal to 6 square root of 2. All right. Okay, in fact, the square root of 2 seems to be quite popular. When you look into the previous question, we had a 4, and then 4 radical 2. Here, we have 6, and 6 radical 2. All right, then let me try to get you the next question, and then hopefully we can find some sort of pattern here. It seems like there is something going on, right? All right, let's look into the next question then. this time. Oh, why not? Let me just try to turn this one around a little bit. And I'll say, this angle is right. However, what if I have to say this side is equal to x, and this side is equal to x? Then what would you realize about the other side? Question mark. What's the relationship? Because this, you will realize that this is basically the same kind of question as the other two, where each angle would have been 45 degrees. So when we can set up the Pythagorean theorem, we will have x squared plus x squared must be equal to question mark square. And we will have here 2x squared must be equal to question mark square. When you take the square root of both sides, and question mark must be equal to square root of 2x squared. Of course, 2 cannot come out because it's not a perfect square, but x could. Hence, this one will be equal to x square root of 2. Alright. Okay, then, wait a minute. And the pattern is, here we have, when two legs are equal to x, the hypotenuse will be equal to x radical 2. And you will also realize that the measure of the angles on both sides will be 45 degrees. Alright, then at this point, what I like to do is, I like to give you a couple of questions and see if you can use this ratio to solve the following questions. Alright, so then, next question that I'm going to give you will be something like this. Okay, given that we have this side, two questions back to back. Both of them are right angles. And I'll say this side here is equal to maybe q, and this one is 2. How about here? This would be 45 degrees. And in this case, the hypotenuse is equal to 2. I want you to find A. Find A. So question number 3 and 4 is to find A. Alright, then, when you look into number 3, you will realize that, hey, this triangle should remind you of the ratio, because two sides are equal to each other. The ratio was x was equal to 2. Then notice, in place of x, what do we have? We have 2. That means, from between these two triangles, we'll realize that x must be equal to 2. What is A? A actually corresponds to x radical 2. That means A must be equal to, since x equals 2, so we will have 2 square root of 2. That becomes our final answer. Now, on the other hand, let's go for the next question. Similarly, we have right triangle, but since one angle is 45, the other angle also must be 45, hence making it into isosceles right triangle. But unlike before, we have the hypotenuse is equal to x square root of 2. That's given. And we want to find out the value of x. Then the equation which we can set it up here would have been equal to this. Since 2 is equal to, from here, x square root of 2. That would be the first equation which we can set up. Then what is the value of x? Yes, all we have to do is simply divide by square root of 2. And you will realize that x must be 2 square root of 2. But if you have to rationalize the denominator, what we can do is we have to get rid of the square root of 2 on the bottom. How'd you do it? That's right. When you multiply top and bottom by radical 2, just like the denominator itself, we'll realize that on the numerator we're going to have 2 square root of 2, and the denominator will be simply equal to 2. And 2 and 2 cancels out, becomes square root of 2. That would be equal to x. But in this case, x is in fact equal to a, so therefore a must be equal to square root of 2. There it goes. Alright, so we were able to solve the questions just right now. Then what if I were to get you a couple more questions? This time, I will give you a square. And I'll say the diagonal is drawn for the square A, B, C, D. Now, I'll say AD is equal to 3. Alright, then I want you to find AC. Now, in the beginning, yeah, it's a square, so all angles are equal. Okay, I give you that. But not only that, these two sides are equal to each other. Wait a minute, so is the other two. But this, when I look into triangle ADC, this one should look very familiar to you, just like the other question. In fact, this will be equal to 3 also. Then if you have to use the ratio of x right equal to 2, you will realize that in place of x we have 3. That means in place of x we gotta have 3 coming in. Therefore, hypotenuse of the triangle, which is the diagonal, you're looking for AC, there must be 3 square root of 2. And we can find this one quite easily by comparison. Alright, and the next question will be very similar, but I'm going to ask you guys the question the other way around. Number 5. Okay, just like the previous question, we have diagonal given. Let's call this one as A, B, C, D. This time, in square, A, B, C, D. CD is given already, or AC is given, as let us say, how about 12? Then what is, maybe find AB. How are you going to do that? So, if you have to look at the previous question, we get to see that AC is equal to 12, and we're looking for this one. And since this is a square, each side will be also equal to each other. So yes, we can use the Pythagorean theorem if you want to. So first method would have been yes. Since this side is equal to x, the other side also must be equal to x. Hence we have x squared plus x squared will be equal to 12 squared. And then continue from there. You're going to getting 2x squared must be equal to 144. X squared must be equal to 72, where x must be equal to, when after simplified, 6 square root of 2. But how else can we do this? Here you see, if you have to remember the Pythagorean triple, this side, these two sides were x, and then hypotenuse was x square root of 2. You see, in place of x square root of 2, we have 12. That means we can set up an equation. X square root of 2 must be equal to 12. Of course, we're going to divide by square root of 2 on both sides. Then x must be equal to 12 over square root of 2. But we can still rationalize the denominator by multiplying by square root of 2 on both sides. Then you will realize that we have 12 square root of 2 over 2. How can we figure out the answer? When 2 and 12 cancels out, we have 6 split it up 2. That becomes our answer. As you can see, the answers are equal to each other. All right, so that's it for today, and I'm gonna post some more practice questions. Have a nice day. Bye bye.